Hi guys, this is Maverick Pond, the chemistry guru. Now in this video, we want to go through the suggested solution for 2019 A-Levels H2 Chemistry Paper 1, question 20. Okay, let's take a look at question 20. Question 20, compound X is a chloroalkane of molecular formula C7H15Cl. It undergoes a hydrolysis reaction when warmed with an excess of aqueous sodium hydroxide. When the reaction is complete, the major organic products form a racemic mixture. So what could be the identity of X? Now this question is focusing on the nucleophilic substitution of halogenal alkane using aqueous sodium hydroxide heating under reflux. So we should have learned that nucleophilic substitution, there are two possible pathways, SN1 mechanism and SN2 mechanism. So if I consider this statement here, forming a racemic mixture, it should remind us of SN1 mechanism. So it actually suggests that my compound X, it has a chiral carbon. So therefore, this information, I actually have this here. If I have C7H15Cl, which is the molecular formula for X, and if it undergoes nucleophilic substitution reaction with sodium hydroxide to form C7H15OH, and the question mentions that the product has a racemic mixture. So if it is a racemic mixture, means that it needs to have equimolar mixture of two optical isomers, and each optical isomer, of course, it needs to have a chiral carbon, because I need to have a chiral carbon, which is a carbon bonded to 4 different groups in the first place, and it is asymmetrical, and then it can form optical isomers, which can have optical activity, right? So therefore, this product will have a chiral carbon, which also means that the reactant will also have a chiral carbon. Because this conversion, it is just a substitution of a Cl group to an OH group. So if this product it is chiral, this reactant must also be chiral. So the next thing that we will have to consider is what are the types of halogenal alkane that will favor SN1 mechanism. Because at the beginning, when I look at this option A, B, C, D, it is just different permutations of my chloroalkane. So probably what we will be thinking of is, okay, maybe I will have two possible species that are chiral. Then I consider which one it is a tertiary halide, because under nucleophilic substitution, we have learned that the type of halogen actually will favor a certain pathway. If it is a primary halide, it will favor SN2 mechanism. If it is a tertiary halide, it will actually favor SN1 mechanism. Again, we are not going into detail, but in general, if I have a tertiary halide, then it will favor SN1 mechanism, because SN1 mechanism, it is a two-step mechanism. The first step, it is to form a carbocation. So a tertiary halide, when it forms a carbocation, the carbocation will look something like this. I just draw these 3 R groups, and this carbon, it is carbocation, so therefore it will be positive charge. So a tertiary halide, when it undergoes SN1 mechanism, it will lose the X minus or the halide, and it forms this carbocation. Now this carbocation, because it is attached to 3 electron donating R groups, so all these 3 R groups will donate electrons or push electron to carbon. So you make this carbon less positive, and this is stabilizing. So a tertiary halide will form a more stable carbocation. So in turn, it will favor SN1 mechanism. So what this means is we will have to look at the 4 options, A, B, C, D, and there are 2 criteria we will want to fulfill, right? The first criteria is, do I have a chiral carbon? It has to be a chiral carbon in the first place. Then it can form a racemic mixture. Then the second thing is, out of all these chiral carbon, which one of them it is a tertiary halide? If I have 2 possible options where I have both chiral carbon, one is a primary halogenal alkane, one is a tertiary halogenal alkane, then I will choose the answer with a tertiary halogenal alkane. So with this consideration, let's run through the options A, B, C, and D. Now option A. Now option A is CH3 bracket CH2 bracket 6 Cl. So this CH2 bracket 6, it is interpreted as a straight chain, CH2 6 times. So it will be something like this, CH3, CH2, 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 Cl. Of course, this guy is non-chiral, so therefore A would be eliminated. Remember what we want is we want a chiral carbon. Then if it is a chiral carbon, then we prefer it to be a tertiary halide. So A is out because it is non-chiral. How about B? B, it is a bracket CH3, CH2, close bracket, 3, carbon, Cl. So this guy, if we draw out, it will be interpreted something like this. Now this carbon here is actually this guy. So this carbon, it is attached to 3 ethyl groups. So this is the first CH3, CH2. This is the second one. This is the third one. So I have 3 of these ethyl groups, which is here, attached to this yellow carbon, attached to a Cl. So this guy, it is non-chiral because chiral carbon must be bonded to 4 different groups. So again, B is eliminated. Now how about C? Now C, I have a CH3 bracket 2, CH, CH2, carbon, bracket, CH3, bracket 2, and a Cl. So if I draw out this guy, it will be something like this. So again, maybe if I color coded this yellow carbon, it is here, attached to 2 methyl groups. These are the 2 methyl groups. Then followed by CH2, which is this guy, followed by this blue carbon, which is here. This blue carbon is attached to 2 methyl groups, then followed by a Cl. Again, if you consider this carbon, this blue carbon, this is non-chiral. So therefore, the product cannot give me a racemic mixture. So actually options A, B, and C, none of them are chiral. Then the answer has to be D, right? So it is not particularly interesting. By right, it will be a little bit more interesting if I have 2 options. Both have chiral carbon. Then one, it is a primary halide. The other one, it is a tertiary halide. Then it will make us consider or make us think of the SN1 versus SN2 mechanism involving the different types of halides. But this question is a lot more straightforward than expected. Let's run through the last option. Option D, CH3 bracket 2, CH, then a carbon bracket CH3, then close bracket another CH2CH3, followed by a Cl. So this yellow carbon, again it is here, attached to 2 methyl groups. The one that we're interested in is this green carbon. This green carbon, it is attached to a CH3, which is here, an ethyl group, which is here, this 2 carbon, a chloro group, which is here, then followed by another group, this carbon attached to 2 methyl groups. So obviously this carbon, it is attached to 4 different groups. So this is my chiral carbon. And this carbon, it is also a halogenal alkane, obviously. And also very nicely, it is a tertiary halide. So what this means is this option D will have to be my answer. Alright, so that was the discussion involving question 20. Now question 20, it is testing us on nucleophilic substitution. So based on the information given in the question says that I have a racemic mixture. So therefore, the mechanism has to go by SN1 mechanism, and we have to look out for the presence of a chiral carbon. So if you have learned something useful from this video, please give me the thumbs up, like this video, and subscribe to my YouTube channel for more weekly video lessons. That's all for now. Thanks for watching.